Thanks very much for the introductions. I think the AI did a pretty good job in carving out the introductions. I think it would transform our way to teach our students how to write, because I'm sure the students are going there to write their essay now. So first of all, I would like to thank again for the school to invite me to come to here to speak in this lecture series again. It's been a long while since I visited Seattle and UW. I think it was before the pandemic. It's really good to be able to come here in person, meet with friends and colleagues, and be able to catch up with them in person. So thanks very much. Today I'm going to talk about a topic that I'm really enthusiastic about as one of my latest research directions, which is looking at the future of the oceans in the context of the nexus of a number of global societal and environmental challenges, food security, climate change, and biodiversity conservation. Of course, these are huge topics that I think many colleagues in the world are working on, including many colleagues here in the in SAPS, and many of you are doing amazing works on these aspects. In this presentation, I will be focusing on drawing example from my own research, but I'm not saying that I don't recognize all this work. It's just that I will use that as an example to illustrate my point, as well as provide an example to further the discussions from there. And I hope that this also provide a starting point for discussing about opportunities for exchanging ideas or even collaborations. Okay. So this is an outline of what I'm going to talk about today. I will first of all highlight the significance of addressing this topic, the nexus of biodiversity, food security, and climate change. I will then explore how the food, climate, and biodiversity nexus is related to some of the selected key challenges to achieve, or is related to challenges that are required to solve in order to achieve a sustainable and desirable ocean futures. And I will then talk about how we are going to address these issues, particularly focusing on the idea of the need to develop a portfolio of solutions that fit with local context, both social context, economic context, and ecological context. So as you all know, the food security is one of the global societal and environmental challenge. The global population is increasing, and is projected to increase by a little bit more than 2 billion people in the next few decades. At the same time, economic wealth has also been growing. These are driving force for a rapid increase in global consumption, including food consumption and food demand. There's a lot of advancement in our food system in meeting that demand, but still, there are hundreds of millions of people that are still suffering from hunger and malnutrition. There's a real problems that affect people in terms of food security that we need to address. And with a global growing population, that challenge will continue to be there. Just to put it in a bit more context for the oceans, some of you may recognize that this is the global trends of fisheries productions from the oceans from both capture fisheries and mariculture, so marine aquaculture, in the last 6 decades since 1950. Except that on the left-hand side, we change it to a different unit, which is the percentage change in the estimated nutritional content of the different species that are included in the fisheries production. So there are 4 different nutrients that are really important for the nutritional health of people: calcium, iron, omega-3 fatty acid, and protein. So all of these trends show that there's a remarkable increase in the availability of these nutrients from seafood since the 1950s, but then it peaks in the 1990s, and it seems like it is leveling off. And if you look at the breakdown of the contributions from fisheries, aquaculture, as well as from the different types of species, we find that for fish, there's a that strong decline since the 1950s, since the 1990s. But for invertebrates, it seems to be increasing from capture fisheries as well as from aquaculture. But still, that increase doesn't compensate for the decrease from finfish. At the same time, although there is a lot of enthusiasm about aquaculture compensating for the limits of production from capture fisheries, but at least for marine aquaculture, the increased production from mariculture does not also compensate for the decrease from capture fisheries in terms of nutrient production as well as biomass production. So that highlights that we see a limit of the oceans in supporting solutions to food security, and that's something that we need to look into in the future. And then, of course, there's the issues about climate change. Climate change is affecting many aspects of life on Earth, and we now know that it is one of the biggest challenges to sustainable development for our society globally. And the oceans, the ocean has been helping us by absorbing carbon dioxide and absorbing added heat from human activities, particularly from burning of fossil fuel. But then in doing so, we are also changing the oceans. We are causing ocean warming, ocean acidification, the loss of oxygen in the ocean. And at the same time, there's more frequent and intense extreme events such as marine heat waves. And many coastal communities are also facing the increasing risk of associated with sea level rise as well. So all of these are putting more hazards that are related to any of the ecosystems and the dependent human communities on the ocean ecosystem. And to give myself a reality check of what climate change is affecting us, and actually we are really experiencing these changes just at our doorstep. This is the observed change in sea surface temperature in the 3 Canadian oceans, so the Pacific coast, Atlantic coast, and the Arctic coast. You see that remarkable increase in sea surface temperature, particularly in the Arctic, where the changes in sea surface temperature or increase in sea surface temperature double the rate of those in the Atlantic and the Pacific coast. So that really highlight that it is not something that is going to happen. It is happening, and that it is happening really fast, particularly in some of these vulnerable regions, such as the Arctic. We also have robust evidence that these changes are affecting marine ecosystem and some of the activities that are dependent on it. This is based on the assessment by the Intergovernmental Panel on Climate Change, the IPCC. As the introduction mentioned, I'm involved in as an author in this assessment. What we did is we synthesize available scientific information and provide a synthesis of what the current risk, impact, and vulnerability of the system, of the marine system, and some of the sectors in terms of climate change. And we find that there are robust evidence that all of the marine ecosystem in the world are already facing change. I'm just highlighting those that are particularly relevant to here, the North American system and the Arctic, where we are seeing shift in ecosystem structure, changes in species range, distribution range, particularly a shift towards the high latitude regions or deeper water for many species, changing of the timing of the biological events, or we call it phenology, and also changes and impacts on fishery use and productions. In many species, the impacts are negative, meaning that there has been a decrease in productivities or production potential, while some species may benefit in North America. And so far, I think a lot of the evidence in the Arctic, although we are expecting positive benefits, benefit or positive change of increasing availability of some species in the Arctic. But interestingly, the evidence is, at least from the literature, showing that most of the evidence that we see are negative impacts so far in the Arctic. So all of this actually also means that we need to deal with climate change when we look at how we can develop a sustainable oceans for the future. But then there's the cost-cutting, the changes of biodiversity loss. Climate change certainly is a factor leading to biodiversity loss, but then there are many other factors driving that as well. This is a census figure from another international assessment, and this is assessment is focusing on biodiversity and ecosystem services. This is the Intergovernmental Platform on Biodiversity and Ecosystem Services. So again, similar to IPCC, they focus on series of literature and scientific evidence, but looking at the changes in biodiversity across biomes, land, ocean, and freshwater. And they highlight that all of these systems are facing or have been facing declines in the nature. So either diversity or extinction risk or like actual extinctions documented, or decrease in abundance or biomass, including the oceans. I mean, the oceans, the assessment highlighted historically direct exploitations like fishing is one of the main contributing factors to the declines in nature. In addition to that, we have climate change, invasive species, pollution, and other factors as well. And recently, colleagues have been also pointing out that in addition to identifying the declines in nature or biodiversity, we need also to start thinking about how we can, what they call the bending the curve. So we see that historical declines in nature as a black join there, but then what we need to start thinking about is how to bend that downward curve and then shift it upward. And in this case, this is the paper published in 2020 by a group of colleagues that work on terrestrial biodiversity. So they develop numerical models. They call it the integrated assessment model, and the land use model that look at how in what pathway they can bend this curve of changing from a degradation state up to something that is more desirable in the future. And that's something that we're starting to see the need for the oceans as well. I think colleagues has been starting to explore that that bending the curve on different specific regions or on different specific sectors. So I think that's something that is emerging and is needed to do too. But then what it really required is also a shift from the silo of traditional silo of looking at these challenges separately. So traditionally, either like the government setting or the international policy discussions often separate these problems like they don't relate to one another. There are specific policy discussions for food security, for climate change, or for biodiversity loss. But it doesn't make sense because, I mean, you know that they are all interrelated. Climate change relate to biodiversity loss, while losing biodiversity obviously affects our ability to produce food, particularly wild food, like fisheries. So we need to change that mentality to look at it at more of a nexus concept or framing, that we need to look at the interactions between these different challenges. Both positive and negative interactions and how they interact with one another in order to find the solution space that would actually be able to address these different challenges altogether. Either find trade-off, also thinking about where they can have co-benefits in having actions that can hit multiple problems. So I think fisheries is a very good example of that because it relates to the three different challenges. Climate change is affecting fish stock, fisheries, marine ecosystems, and that there is a direct relationship between the nature, marine ecosystem, and fish stocks to multiple types of well-beings of people, food, livelihood, and culture. But at the same time, our activities to generate those benefits would affect our fish stocks. And also, there were increasing evidence that marine ecosystems, fish invertebrates also contribute to climate or carbon sequestrations. So that provides like a really good example of these nexus of climate, food, and biodiversity, and also how we can actually solve that problem for the oceans, for fisheries, but then also use it as maybe something that can be transferable to other systems as well. So before I move to the further about the specific challenges that we will dive into, just want to mention that a lot of the research outputs that I'm going to show as to illustrate my point come from numerical modeling and scenario. So that's one of the main tools that I use in my research. Particularly in recent years, I've been spending, and my team has been spending a lot of time developing integrated modeling for the oceans that try to link the ocean changes with changes in marine species and how that affects fishing and aquaculture, and how that relates to more of the human dimension through the economics of fishing and the food system, and how the bigger world changes will affect that, such as changes in populations, changes in economic growth, and things like that. And so I won't go into the details about modeling, and I know this audience have lots of numerical modelers here, but if you want to get into the details about that, maybe we can also talk about that after the seminar, and happy to dive into details about that as well. So moving into the second part is to then highlight some of the challenges that we need to address in dealing with these nexus, food, climate, and biodiversity. I mean, there's so many challenges, so I won't be able to cover all of it even in a whole class, not let alone just one seminar. So I picked two challenges that I feel that they are really important, that I think is something also where I'm working on right now. The first one is on the disparities in impacts, risk, and vulnerabilities between different regions or different communities for the challenges. And then the second part is about the need to resolve the trade-offs or identify co-benefits associated with achieving food, climate, and biodiversity targets. But let's go into the first challenge, which is about the disparity that relates to social equity, and which is something that is mentioned in a lot of the discussions internationally, nationally, and locally as well. And we know that the world is not equally, it's not the same everywhere, like geographically. There are differences, for example, in terms of the dependence on seafood as a source of nutrient, for example. And this is the estimated consumptions of proteins from fish across different countries. And we know that some regions, such as Southeast Asia or Africa, particularly West and South part of Africa, are much more dependent compared to, say, North America. And we know that even within North America, there are really big difference in terms of our dependence on fish and the oceans. Like this is a global study, but then it also applies to like in a national scale as well. This is from colleagues from the nurses program that I try to estimate the consumptions of indigenous people of fish by indigenous people compared to the rest of the population. And I think the conclusion is that indigenous people consume much more fish, like you see the number, several times more than the rest of the population. So within the country, or within the regions, we know that there are people, like the indigenous people, for example, are much more dependent on fish for the diet compared to other people. And then there are also disparity in terms of our ability to respond to changes. And when, I mean, the economic wealth is not a direct indicator, but it tells us a lot about kind of the capacity of the different countries in addressing some of the issues. The idea is that more wealthy countries will have a more capacity, more resources in their disposal to address some of the environmental challenge that they are facing. So again, you clearly see differences where like regions where they are most dependent on fish are those that have the lowest, in this case, economic wealth or development indicated by GDP, or gross domestic product. And this is the same too for fish. I mean, the fish are not evolved equally. I mean, fish, some species are more tolerant to warm water compared to the other. Some have a much bigger scope to adapt to changing ocean conditions than the other. And we actually see that affects how the fish and fisheries respond to climate change, for example. It is a study that we did a few years ago, quite a few years ago, almost a decade ago now. We look at the global fisheries data, and then we analyze the different species in relation to their preference for temperature. So there are fish that are warm water associated. Also, there are fish that are cold water associated, meaning that they tend to more prefer warmer water or colder water. They tend to be not able to tolerate warmer water or cold, or the opposite. And then we compute an index called the mean temperature of the catch, or MTC here in this figure. So what it means is that it is an average of the tolerance of the temperature that the species can prefer, weighted by their catch in the fishery. So fisheries will have a higher temperature of the catch if it is caught in the it is from the tropics, because they are catching more warm water preferred species, compared to a fishery, say here or in Alaska, where they are catching more cold water species. Yes.
Yeah. So is this why EEZs in higher latitudes would possibly benefit from extreme temperature rises?
Yes, so there's relation there too, because then species can shift their distribution. So species that adapt to warmer waters will be able to change their distributions as the oceans warms up, and often it is shifting towards high latitude regions where with warming, the environment becomes suitable for them to live. But in here, we look at the fisheries at a different kind of individual system. And then we look at this index, and we find an increasing mean temperature to catch globally and as well as in specific region. And this figure is mainly focusing on the mid to high latitude. So like regions around here is considered to be mid latitude temperate region. So we see an increase in the mean temperature to catch that relates to increasing dominance of the warmer water species, as you said. And then it also relates to the changing ocean temperature. And more recently, we followed on that analysis, and then we asked the questions of, so we see changes in the fish compositions in the oceans, as well as in fisheries catch. Is it affecting us who don't go out fishing and we go to restaurant to enjoy our seafood? So my students, John Paul and I, did a study that looked at restaurant seafood menu. So we think that that's a good indicator of what fish are served in the restaurant. So we look at it for restaurants in North America, and we selected Vancouver as our kind of main focus, but then we also include Los Angeles, which is south of British Columbia, and Anchorage, Alaska, which has a kind of northern area. And we also look at menus that dates back to the last century. So we went to the museum and then get the archive there, and we compute a similar index, but then in this case, an index for the species appearing in the menu. We call it the mean temperature preference of the restaurant species. And we find that similarly, we see an increase in the seafood that are all served in the restaurant, at least in Vancouver, and that we also find that species served in the restaurant in Alaska is actually colder compared to restaurant serving species served by restaurant in LA. So that makes sense too. So what we are suggesting is that okay, these changes are also cascading into changes and affecting the food that seafood that people living in the city are enjoying. So they may be actually eating more of the seafood that are from that they don't enjoy before with climate change. And just I include that it's just for fun because it's a interesting collaborations coming out from that study. Colleagues from Arizona State University contacted us and they find that this is interesting because it connects climate change to oceans to people through seafood. So they are these colleagues are artists, and so they develop these art installations that try to reflect these changes of fish in relation to the menu. And so yeah, I just think this is fun to include. But one thing that I'm thinking is that we know that, okay, we may not be able to enjoy the salmon here as much as we used to, or maybe we may need to pay a higher price. But still, I mean, the level of impacts in terms of affecting us is, I don't think it's much. I mean, people can shift to other species when they go to restaurants fairly easily. I don't think that people actually care that much about that. They go to restaurant and then just look at the menu and see like what are available. But then for other people, it is a big deal. For example, the indigenous coastal communities that I mentioned. So this is a study that we did using our simulation modeling to project changes in the fish stocks that are important to coastal First Nations in British Columbia. So that includes salmon, herring, and many other species as well. And we find that under at least from our simulation modeling, with projected climate change, most of these culturally, historically, traditionally important species to coastal First Nations are going to decrease. And that's a big deal for them because the culture and the food system is developed around these species. It is not the same if there are more squid available or more tuna available, while salmon is declining because the kind of processing that is required to make the fish accessible to the community is just different. They develop the whole processing like smoking of fish and things like that around particular species, and it is just not directly transferable just by other species. And that's also creates challenge, and these communities also have a particular challenge in responding to these changes as well. And we continue with these studies, and this is one of the ongoing projects that we are doing, working with the coastal First Nations to try to identify the pathway that they can adapt to some of these changes, particularly in view of securing the nutritional health of the coastal First Nations. And what we find is that when we try to develop what we call a system mapping, with the communities, we ran a participatory workshop, developed a system understanding about the linkages between fish and different pathway to consumptions by the First Nations. We find that there are lots of factors that is actually outside of the oceans, outside of the climate, outside of the fish that are affecting or creating barriers for them to adapt to changes or to get more access to available resources, such as, for example, the ability to transfer the traditional knowledge to the younger generation, or that the time that they can secure to go out to fish compared to the time that they need to go out to do their day job, because many of them now have to work in normal jobs like us, and that the time they can spend for traditional activities such as wild food collections or hunting is much more limited. So this exercise highlight that we really need to think about it in the broader sense of how to allow the committee to be able to adapt and respond to these changes that we are seeing and expect to see more in the future. But then there are also another side of the challenge, which is a bigger scale difference or disparities between different regions of the world. So we look at it at the mid to high latitude perspective, but then when we look at the tropical perspective, it is a different story because the tropics is already kind of the warmest parts of the oceans. So there won't be new species moving to that area. So some of the species may be able to tolerate the increasing temperature because, I mean, they evolve as particular adaptations to deal with warmer temperature, but many of the species won't. So we'll be seeing a decreasing diversity in the tropics, and probably also a decrease in availability of the fish as well. And that show up in our analysis in the mean temperature to catch, where we see an initial increase in mean temperature to catch, but then in level off. And what we suggest is that it is because some of the species that are sustaining at the high high level of the catch are those tolerant species, while species that are not be able to adapt, that prefer cooler waters, are shifting away from the tropics. And that then combined with all the type of disparities, social and economic disparity that we talked about earlier on. These regions are also those that are most dependent on fish as protein and micronutrients for their nutritional health. And that show up from like the blue color means in the oceans a big decrease in projected potential fisheries catch, and this is projected from our simulation modeling. And then the color on land are the dependence on fish as a source of protein. So you see, unfortunately, overlap in area that's high dependence on fish, as well as projected large decrease in catch potential. And even when we add the picture of mariculture, again, there is a lot of hope that aquaculture can solve the problem. So we add aquaculture modeling into our simulation exercise. So we have developed models to look at aquaculture or mariculture in this case. So it's just marine mariculture, not freshwater. But in this case, a lot of the existing mariculture are still rely on the open waters. Imagine farm, I don't know whether you've seen salmon farms in this coast. Basically, the fish are kept in a net cage where they rely on basically the natural water still. So changing ocean conditions will still affect those species living in those facilities. This is the same for many of the shellfish aquaculture, like oyster farms, where they basically is an open system where they rely on the waters, the natural waters to farm the species. So changing ocean conditions will still affect those mariculture productions. And if we factor that in our calculations, the tropical countries will continue to be the most highly impacted countries. And on the figure on the left-hand side, right-hand side, we included the projected populations for each of the countries. And because that is another side, there will be increasing demand for seafood, particularly when the population is growing, assuming that their consumption rate continue to remain the same. And so that becomes an increasing gap. Those countries that have a high demand for fish, their population is growing also very rapidly, and that they are really projected to be decreasing in terms of availability. But those countries will be having a hard time in catching up with having seafood to provide the nutrients and food that they need to support their nutritional health. And just seems like this is already such a big problem. So in some of the recent work, we highlight also the challenge of the extreme events. In this case, the extreme temperature events such as heat waves, because a lot of our work and work on changes in the mean conditions, so long-term change averages. But then, as you know, and as you now experiencing in here, that extreme events actually have big impacts. The temperature or precipitations or storm surge and things like that. So here we focus on the temperature extremes and incorporate that into the modeling to see how that adds to the constant challenge of changing ocean conditions in the long term and how that would affect our species and fisheries. And what we find is that it really adds to the impacts from the long-term mean changes with the extreme events, extreme temperature events. So in some cases, for some species, it can double the impacts when the extreme events happen. Like in the North Pacific, we did a study that focused on the North Pacific and analyzing using our models to study the effects of an event that is similar to the extreme event, heat wave that we've seen in the last few years in the North Pacific. And for some species such as salmon, the impacts basically will be doubling the impacts that they are having from the long-term mean climate change. And those kind of impacts really then cascade into the impacts on the economics and the livelihood in terms of their employment. So this is based on results from our integrated modeling that try to link the changes in oceans, fish stocks to the economics of fishing. So there are lots of information in this map. I won't go through that. But one thing that I want to highlight is that the left-hand side are maps that shows the extreme events impacts. The right-hand side are maps that shows the long-term mean impacts. So the overall impacts when an extreme events hit a countries or hit a regions on top of the long-term climate change impacts are the sum of the two maps. And particularly, I want to highlight that the area that are most impacted both by the extreme events and the long-term mean climate change are also those areas that I highlighted previously. The West African regions, tropical Indian Ocean, Southeast Asia, and West African region. So again, highlighting the big challenge that these countries are facing. Not only the loss of availability of seafood, but then also impacting the economics in terms of the revenues generating from the sectors, as well as the number of jobs that can support from those sectors and the resources. So I think the other aspect of this is then to resolve the trade-off associated with these different challenges. We know that these are big problems and that we need to find solution to that. But then because of the complexities of the system, it means that there will be area where we need to make decisions of investing on one more and the compared to the others, while there are areas that we can identify key co-benefits. And basically, this is something the economist has been working on a lot of the time, which is in a concept called perpetual frontier. The concept basically is that the green area represents the theoretical kind of area where we can maximize the benefits, either food, climate, and biodiversity. But then if you hit that surface, you need to make decisions about whether you want to go to one direction or another, because you cannot improve from one target without sacrificing or reducing on other targets. So that means that you have to make trade-offs. And the thing is that often our current system is still suboptimal, so there are lots of scope of improving in multiple dimensions, and where you can actually have a lot of co-benefits by doing interventions that can actually move us towards more of the goals along that green surface. And so I would use the North Atlantic, in this case, the Northeast Atlantic, as an example of like how this needs to be factored in developing solutions for the nexus of food, climate, and biodiversity. And we know that in the Northeast Atlantic, particularly in the European waters, many of the fish stocks are still considered to be overexploited, and under the European common fisheries policies, they are mandated to there's this policy directive to develop rebuilding plans. I think it's like the US, where they need to rebuild those stocks towards a particular specific targets that they agree on. And right now the target is maximum sustainable yield, which is the targets. And this is based on a study that looked at the status of the fish stocks in the Northeast Atlantic, just an indication that there are still many of the fish stocks that need to be reduced, particularly in the southern part of European waters. But then when we think about rebuilding, we need to think about how we can achieve that with a climate change lens in it, because we know that climate change is affecting these fish stocks and their future. So, and particularly if we look at this plot, which is a reanalysis of our simulation modeling, but then in this case, we express it by the global warming level, which a lot of the policymakers are now talking about whether we want to go to a world of 1.5 degrees Celsius versus 2.6 degrees Celsius or versus 3.55 degrees Celsius world, and they refer to a global mean warming relative to pre-industrial level. while the lines and the dots are the projected changes in biomass. And there are two scenarios here. The upper part is a scenario that meets the current targets of fisheries management, which is at maximum sustainable yield. While the lower is more of a scenario for overexploitation. Yes, too much fishing. The fish stocks are beyond where they can achieve that maximum sustainable yield. But then you see that the warmer the waters are, the less of the available biomass are there. So that's in general, that is from our simulation modeling for the Northeast Atlantic. So what it means is that if we set a particular goal for rebuilding, it probably will be no longer relevant with climate change affecting the availability of fish. And at some point, for some fish stocks, even if we try to rebuild the fish stocks, but then factoring in climate change, we may just be able to maintain the current level of biomass because climate change at the same time is lowering the biomass while we try to rebuild it. So we need to factor that in our rebuilding. So we look at the different fish stocks in Northeast Atlantic and try to combine fishing scenarios with climate change scenario in it. And then we look at how different scenarios would do in terms of rebuilding these fish stocks. And we express this as the biomass of the fish stocks under different warming scenario and the fishing scenario as well. And the take-home message is that what it suggests is that if we maintain the current biomass targets, we need a much more conservation-focused targets compared to the current focus on maximum sustainable yield. So it means that we need to further reduce fishings in order to adjust for the impacts of climate change, and that this is something that is needed to think about for the management agencies in European waters that there's that need. They cannot just assume that things are the same when they factor in this rebuilding plan. But then again, that applies to the mid to high latitude. But in the tropics, they are facing even more challenge because even a global warming at 1.5 degrees Celsius level, which is meeting the international targets, which we don't think we can meet under current international actions to climate change, they will still have problems getting any of their biomass of fish stock to rebuild if they are overexploited. So we estimate that the limit to rebuilding expresses by temperature, global warming temperature, and in some of those regions, such as the North Indo-Pacific regions, the limit is below 1.5 degrees Celsius. So unless you are really doing a good job in limiting global warming to 1.5 degrees Celsius, there's actually really difficult to rebuild fish stocks, overexploited fish stocks in those areas because of the big impact of climate change. And at the same time, this also is a challenge for those areas because, okay, they can reduce fishings even further. But again, those areas are those regions that really rely on fish. So reducing further fishing, meaning that they need to find ways to compensate for the fish, for the livelihood, and things like that. So that's something that like a trade-off that we need to think about. Okay, I'm just going through this really quickly because I want to go to the last part. It's one thing that besides the trade-off, I think that there are also co-benefits. And one of the co-benefits that we have identified in our study is the contributions of fish stocks to climate change solutions. Previous studies suggested that the fish can capture carbon, and some of the fish, when they die, they will sink to the sea bottom and bring with them carbon. So that's one pathway to carbon sequestration, although the contribution can be low compared to fossil fuel burning, but then that's still a contribution. So what it means is that solving the overfishing problems can allow more fish in the oceans, and that they can do more work on trying to bring those carbon down to the sea bottom. So that, for some of the fisheries, it would make sense as a co-benefit, particularly for those fisheries such as some of the large pelagic fisheries happening in some waters that are only viable, economically viable because of subsidies government gave them. And so that's that's a no-brainer, because so if you remove subsidies, the fisheries will not be viable, and so they will allow more fish in that area, and that would also contribute more to climate mitigations as well. So that's an example of the co-benefits. And then there are also other notable challenges I didn't mention. So I just want to highlight that I'm not ignoring them. It's just that the time that I have does not allow me to go into details of that. And I'm happy to talk about any of those after the presentation. So going to the final part is to find solutions that to meet local context. I won't mention specific solutions that I identify, but then instead I will bring up a project that I'm really enthusiastic about that we just started last year. That are trying to focus on that and finding solutions that fit with the local context. So we have the context that we want to identify a future that are desirable and sustainable. And in doing so, we want to develop visions of the future with inputs together with local communities, with stakeholders, rights holders, knowledge holders, so that we can develop something that see how we can benefit from or relate to the oceans from the natural perspective, from cultural perspective, as well as from the societal perspective. And then we can decide on different interventions that can help us achieve the goals, the desirable futures, like either through direct interventions such as protected area or fisheries management, or more general governance issues such as reconciliations of indigenous governance or aquaculture, and then trying to identify pathways that we can actually achieve that, and then put them together a portfolio of solutions to achieve the desirable ocean futures. So we got funding from the Research Council of Canada, and this is something that we started last year last year in summer. The partnership is called Solving the Sustainability Challenge of the Food, Climate, and Biodiversity NASA's partnership. It is an international partnership. It is a 6-year partnership that include both scientists or researchers, as well as non-academic partners, like NGOs, governments, and indigenous communities. So this reflects in the different partners in the partnership. And the overarching objective is to develop realistic visions about the desirable oceans, because we realize that there won't be one vision. Different people have different visions. So we need to recognize that. And that's why we want to bring these diverse groups of people together to develop that visions, identify priorities, examine consequences, trade-off, co-benefits, and then also use it to develop ways that we can use and transfer to some of the other systems or regions to deal with this necessary challenge of food, climate, and biodiversity. And we know this is a big challenge, so we are not saying that we will solve the world's problem. We will start off with case study, looking at specific aspect of this challenge, particularly looking at some of the focus that the region is already thinking about. For Canada, we will work on in the Pacific, particularly focusing on indigenous community and how indigenous governments can help with solving that challenge. In China, they have been thinking and developing aquaculture for a long time. So we will focus on aquaculture and particularly seaweed aquaculture. In West Africa, Ghana, and Nigeria, we focus on sustainable fisheries management. We particularly focus on illegal, unregulated fisheries. In Costa Rica, we will focus on the land-sea interactions, how management of the land and the sea actually interact with one another for coastal management in the context of food, climate, and biodiversity. And then in Europe, in the Netherlands, they have been thinking about this concept of circular economy. So we want to bring together the available works that they have done and to look at the circular economy concept, particularly with a focus on food, climate, and biodiversity for the oceans. So ultimately, what we want is to see how we can bring this all together to identify pathways and also as well as potential policy and other levers to help provide that pathways towards the desirable ocean futures that are identified by different regions or sectors or communities. So in summary, I think our works highlight that the bending the curve for sustainable and desirable ocean futures really require new framing of the way we look at these different global challenges. We need to look at it at a more holistic view, like look at it as a nexus problem, and that there are multiple challenges that are associated with achieving that. And one of the things that I think is important is to highlight, is to identify ways to address that disparities between regions, between different communities, between different sectors, as well as looking at ways to identify and solving those trade-offs, and also investing resources in those that have key eco-benefits. And then I don't think that there's any single silver bullets to solve the problem. It will require a portfolio of solutions, and that would require a different portfolio in different contexts, social, ecological, economic contexts. And that's why a lot of my work now is to go into the different case studies, working with people, researchers and colleagues there and communities there, trying to develop that kind of local context and the pathway towards solving these problems. So with that, thank you very much, and really welcome any questions and discussions. So
you take the questions for that and go to the queue.
Okay. The questions here and there's this one first. Thanks.
Okay, yeah, I did have a question. So I was gonna ask you, would we have to also manage like top predators during climate change? Because those are other important factors other than like, not just looking for like populations of fish, but also top predators, because they are critical to the food chain during this type of climate change. Would we have to do that also?
Yeah, so I think it depends on what do you mean by control. So I think that this is also a value judgment that required eco-development supervisions with the settings. I think, to me, my value is that I think the top predators like marine mammals, they also have food security issues that we need to secure there. It's not only human food security. Whales, sea lions, seals, they need food security. So we need to find solutions that serve both purposes. And there are trade-offs, as you say, that some of the fish may be affected by that. So I think this is then a question about how we can resolve that trade-off, and as well as developing the vision that would serve with the values that people have in that region, where this is acceptable, like an intervention to really have active control of top predators in a safe way. So I think that's so that, and then.
Predictive models in recent years have been failing due to the unpredictability climate change presented. So in your research and years of experience, which trend or event came as the biggest surprise against one of your models?
Yes, so I think it is the extreme events, and that's why some of our recent research are looking at more closely at those extreme events now. I think the changes are much rapid than we expect, particularly with extreme events. We are seeing changes that we thought will be like a few decades later, but then when the heat waves that last for several years come to the North Pacific, changes just suddenly happens really quickly. And particularly one aspect that I think is gaining attractions from colleagues studying extreme events in the impact is the effects of the compound extreme events. So particularly in this case, for salmon, a lot of our colleagues here are studying that it is not only changes in temperature or heat wave that are hitting that, it is the extreme precipitation, extreme drought, wildfire, and things like that happen all together. So that compound extreme events and their impacts is something that we still don't know much about. And I think that would create an even more surprise when we try to get to know how they are impacting fish stock and the people depend on that. So I have that first and then
when looking at forming case studies with different countries and regions, can you talk a little bit about the importance of where those countries are located globally and what different kinds of data and research you can gain on the different locations of the countries that are forming this case study or the rules for case study?
Yes, so we tried to, when we developed the plan for the project, but initially I think that we're trying to identify areas with different socio-economic contexts, ecological context as well as area of focus that they are working on, so we can diversify that. And that's not, I mean, it is not like a very statistically designed sampling. So it is highlighted like select a case study. It is also built on existing relationships that I have colleagues, I know colleagues working in there that I can develop the collaboration, which is very important in developing this kind of international project as well. But I think that this is a very good question. We are going to have our first big meeting that bring together all these colleagues together at UBC in March. But that's something that we want to talk about is the cross linkages between the case study, how best we can synthesize the experience that we learned from the project, and what are the cross-cutting areas, cross-cutting themes that will emerge. Like in our discussions over the various meetings, the virtual meeting that we had, for example, agriculture seems to be one cross-cutting theme that all the cases are interested in because it's just such a thing that people is enthusiastic about as a potential solution. They want to, and China is clearly a leader in developing agriculture, so they want to learn about the experience in developing the asset and whether that can be applicable to their region.
Yeah, so I was wondering, I was interested in like the menu thing where you were saying how there's a shifting in the menus to the West Coast and some of the states to species that were warmer. I was curious if you had like if you knew like what specific species were they actually the West Coast fisheries, or is it actually more of a metric of consumer preference or globalization and the species are actually Caribbean species? So it's not so much, oh, we're seeing fish shift at the climate change with more where it's these people prefer these species, or these people are just going to be wealthier to say we have the best to choose in these areas.
That's a really good question, and that's like a really big section of CAFIA that kind of say that these are the things that is affecting the seafood that are being served in restaurants. We try to account for some of these changes by eliminating species that are not found in local waters, also Atlantic moving tuna. So we are not including that in our study, and we know that they don't occur in our waters. But still, there are infants on demand. But even with that, I think we highlight some of the species that we know are expanding in the coast of Humboldt Squid. Humboldt Squid doesn't occur in our manual beyond the last 10 years. And it occurred more and more in our manual, our seafood manuals. And we know that those species become abundant, particularly during the warm years, expand to our coast. And traditionally, we don't have big fisheries on those squid, but it seems like it's gaining interest. Maybe it's because of consumer preference, but I think it is, in this case, it may be driven by the increasing availability of the species. And another example is the Pacific sardine. It is not about changing climate in recent time, but then more of reflecting the availability historically. In the 1950s and before that, Pacific sardine is really common in the seafood manual. And suddenly becoming decreasing and less, and it's almost disappearing in our manual now. Just because of the collapse of the sardines fisheries, there are a mixture of reasons for that. Changes, fisheries impact, and the whole body of literature discussing that. But I think that reflects the linkage between the availability of fish and the fish that are serving in the manual too. I have questions. Yeah, here. Go please.
So I think we all accept that marine fish catches are at their limit, declining, but aquaculture catches are going, production is going up. So how does climate change, do you think, going to affect the aquaculture catches? Is that just something that humans can just adapt what fishes or what species they culture, so there's not really a big impact, or is that something we also need to worry about?
Yeah, so for aquaculture, particularly we focus on the culture, so just marine culture. And we look at the current mode of operation. Of course, a lot of them is still relying on the open waters. So climate change is affecting those species, assuming that the operation doesn't change. If they move to the really cold system, land-based, then I think they would be able to separate from the environmental change. But if we do that and we develop models to project the future changes in productions, even those assumptions, we find a need to increase. So there is a possibility of expanding the operation, but then it seems to level off, and then with increasing climate change impact, it actually would decrease under the high emission scenario. But I think we didn't factor in innovations and changing practice and also found new species and things like that can change the picture. But if you're just focusing on the existing operation and existing species, that's what we project. And then, yes.
On one of your slides about the visions for during those solutions, you talk about indigenous reconciliation. And I wonder what that looks like to you and your team, and if you've done work on that, or if that's just like research or projections for the future. And then if you have done work on that, if there's any difficulties with like treaty laws or fishing rights, etc.
Yeah, so we have an ongoing project working with 4 coastal First Nations in British Columbia, trying to look at the interlinkage between climate change, food availability, seafood availability, and then nutritional health. So this is from a team of colleagues, ecologists like me. We have nutritional scientists working on the nutritional side. We have social scientists looking at the cultural aspect, and so governments. And that highlight that complexities. So there are the treaties or the relationship between the community, the governance in relation to the bigger federal system, and that often have a lot of contentions in terms of resource management and the accessibility to fish, as well as the possibility of how they can adapt to climate change. So it is a starting point for the discussion. I think that it is midway through our project. We hope to be able to come up with much more concrete suggestions of some of the ways that the coastal First Nations could use and to help adapt to climate change. I think right now, many of the directions that we're looking at is to identify ways that we can utilize their traditional knowledge in relation to the existing treaty process that they can adapt to some of the changes. For example, there seems to be a limitations of how the kind of species that they can process, because the younger generation does not have that knowledge of processing the fish, like the smoking process. So it means that there may be need to have intervention that promote that transfer of knowledge. And just an example, and we are still in the stage of trying to identify those pathways and then mixing together the results from the natural science and social science component.
Recently, there has been a big push to consume plant-based foods, and many people have gone vegetarian or vegan. How do you think climate change will change its impacts on the ocean now that there will be more fish and invertebrates in the ocean?
Yeah, I think that's good, and I know that there's also a lot of enthusiasm about, for example, farming kelp and farming seaweed. I don't know about this coast, but then in BC, it's just seems to be a big thing now. Everyone, the government putting so many resources into like research in that area, and so the idea is that somehow the seaweed can also provide so go into the food system as one of the aquatic food, new aquatic food. But the transitions is not easy, and that it also doesn't solve all the problems as well in terms of whether seaweed will replace some of the species, fish and invertebrates, and I'm sure like the food industry will find a ways to process the seaweed if there's a demand for that. But I think the transitions need to think through, and I think that's something that we will be seeing a changes in this food system, and how much seafood will contribute to our food system. I think that's something that we need to think through about visioning of what we want to have in the future, and then develop a pathway that would kind of align with solving the three problems, which climate and biodiversity.
I think we should cut it off here. There's an opportunity to speak with Dr. Cheung outside, and let's just thank him.